Hi kids, we will be going into this advanced paper. You can look into the first question. The first question goes like, a concave mirror is placed on a horizontal surface and two thin uniform layers of different transparent liquids which do not mix or interact are formed on the reflecting surface. The refractive indices of the upper and lower liquids are mu1 and mu2 respectively. The bright point source, which is at a height d, which is very large in compared to the thickness of the film above the mirror, coincides with its final image, the radius of curvature of the reflecting surface. So basically this is the question. So yeah, there is a reflecting surface and you are filling with one liquid and thereafter you are filling with other liquid, so both are going to be flat surfaces. This is what they are expecting us to think about. So radius of curvature of this bigger, this spherical thing is somewhere here. So image is forming on the object itself. So how does that happen? If you keep the object here, after the rays passing through this refracting surface, it will be going in this direction. After passing through this refracting surface, it will be going in this direction. It will hit the mirror perpendicularly. Once it hits the mirror perpendicularly, the rays are going to retrace the path. So that's the idea. So what I will be doing is I will be starting from here. The rays are going to hit the mirror perpendicularly, so they will be going back perpendicularly. So if nothing is there, they are supposed to meet at the center. But there is a refraction happening here, so they are going to meet somewhere here. After refraction, they will be supposed to meet here, but again they are going to undergo refraction and they are going to meet here. So immediately after reflection from the mirror, they are supposed to meet here, but after first refraction they will be meeting, they are supposed to meet here, but after the second refraction they are supposed to meet here. So that's the idea. Now I will be using refraction at the curved surface formula, where r is infinity, so mu r by v equals to mu I by u. So I will be using refraction at this curved surface. So incident ray medium is mu2, and object distance, these are the incident rays, this is the positive direction, so incident rays are supposed to meet here, so object distance is plus r. So mu I by u equals to mu r by v. Now refracted ray is going in this medium, so that is mu1, and let me say that image distance, let me call it as v1, right? So that's the refraction of the first curved surface. Now these rays will undergo refraction here, so these are the incident rays for this refraction. Incident rays are supposed to meet here, which is at a distance v1, so this positive direction object distance is v1. In the next case, object distance is v1 and incident rays are in the medium mu1, so mu1 by object distance equals to mu2, which is this one by image distance is d. They said object is placed at a distance d such that image is forming at the same point. This distance is given as d. These are all thin, they said, right? So this is the refraction at the second surface. This is the refraction at the first surface. This is the refraction at the second surface. Now we need to find radius of curvature. I can say these two are equal. So basically these two are equal. I can equate it and I will get the answer, right? Going to the second question. An observer stands at the edge of swimming pool as sketched in the figure below. This observer will perceive the pool as. So basically this is the reality, but how he will be seeing it. Now when a person sees exactly around the normal, there will be a shift, right? But when it is not around the normal and when it is making some angle, we don't derive it generally. At least I don't do, but still you can guess the answer. Anyway, so what's happening, let me show you. So this is kind of derivation, apparent depth, when the observer is not overhead. Generally we used to say when the object is here and when the observer is observing around the normal, then the shift will be like a little upwards, and apparent depth is going to be d by mu and all those stuff. Now he is not observing around the surroundings from the normal, he is observing from an angle. Now the derivation, it will turn out to be something like this. Anyway, the derivation I'll show you in a slightly different way. So basically this is the derivation. There is an object here, and a man is observing from here. So these rays, there are many rays, but which rays will be reaching his eye? The rays which are supposed to go this way, after refraction they will be reaching his eye. Now this first ray, which is going at an angle alpha here, so if this angle is alpha, this angle will be alpha. After refraction it is going at an angle beta. Now the next one, it is making slightly more angle, alpha plus d alpha, so this will be alpha plus d alpha. It is making an angle beta plus d beta here. Now these two rays, when I extend them, I will be feeling like they are coming from here. So basically if an observer is here, you will be feeling the image is getting formed here. So this is the actual depth and this is the apparent depth. We need to find this by this. Now for that, what I will be doing is, I will be using Snell's law here first. Mu sin alpha equals to 1 sin beta. I will be differentiating on both sides. Then for these two triangles, look at this triangle and this triangle. For these two triangles, this length is the common length. So I will find that length from both the triangles and I will equate them. That's the idea. So now if I take this triangle, this is h, this is alpha, so this will be h by cos alpha. Now if I take this triangle, and if I use sine rule, h by cos alpha by this angle is 90 minus alpha plus d alpha. So sine 90 minus alpha plus d alpha will be cos. So h, that thing, this by sine of this angle equals to this by sine of this angle. Now that angle is small, so I can write it as d alpha. Now this question mark is nothing but this length. Now similarly, I will do the same thing for this triangle also. Now from this triangle, if this is h dash, this will be h dash by cos beta, because if this is beta, this will be beta, right? Now from this triangle again I can use sine rule. So this length by this angle equals to this length by this angle. Now I need to find h by h dash, so I will be dividing them, h dash by this. When I divide them, question mark will get cancelled and I will end up getting something like this. Now d alpha by d beta I can find from here and I can substitute it back and I will end up getting h dash is depending on beta and alpha. Now beta and alpha, beta is not independent, beta depends on alpha, right? Beta depends on alpha. So basically you can utilize this equation. Even if you want, you can see when beta is 0, alpha will be 0, which will give us our regular equation, right? So if you want, you can use this equation and you can see what is happening here. So when alpha increases, then h dash depends on the alpha, like this, right? Now if you don't want to do that, you can see the rough ray diagram. So if a person is observing from this surroundings, he will be feeling the image is here. If a person is observing from this surroundings, he will be feeling the image is here. From this surroundings, image here. From this surroundings, image here. So it's like the far away you are going, the upper you are feeling the images, right? So that's the ray diagram we have drawn. So the farther you go away, the upper you will be feeling the images. But in the surroundings, it looks almost the same. So without doing that manually, you can just eliminate the options. When you go far away, you will be feeling like it is more upper, and in the surroundings, it is going to look almost the same depth. So you can eliminate those options. This is wrong. This is wrong. Now these two seems almost same, but this length is almost constant. In the surroundings, we know shift is d by mu. So you can eliminate the options and you can mark option here, right? The next question: two identical isosceles thin prisms of prism angle A and refractive index thin prisms, they said, and refractive index mu are placed with their bases touching each other. The system acts as converging lens. What is the focal length of the system for parallel rays at a distance h from the base of the prism? So that is small angled prism. So deviation is going to be mu minus 1 into A, assuming they are going to hit at small angles. So deviation is, now this ray which used to go like this, it will be deviating. This ray which used to go like this, it will be deviating, and they will be meeting here. Now that deviation, let me call it as delta. So if this is delta, this is also going to be delta. Now that delta is mu minus 1 into A for small angled prisms when they hit at small angles. Now tan delta, what is tan delta? Tan delta is h by this thing. This thing is called as focal length. When you send parallel rays, they are meeting somewhere, we call it as focal length, right? So tan delta is h by f, delta is small value, so I can say delta is almost equals to h by f. Delta is mu minus 1 into A for small angled prisms. From here we will be getting the focal length, right? Going to the next question, figure shows a glass cube surrounded by 4 glass prisms in a very close proximity of its sides. The path that will be taken by 2 rays incident normally on the sides of the prisms are, see again, I am not sure, they have given none of this, so I don't know why they give none of this, because they never give any information about the angle, so you can't predict exactly what is happening. But what they are expecting from us is this ray. There is only this ray and this ray. This ray, it will be partially refracting. See, there is only small air gap, and this ray will be parallel. So this ray will be partially refracting, partially reflecting, and that ray will go here. So out of this ray, partially refracted ray, after refraction it will go here, and after reflection it will go here. Now this one, it will be partially reflected and partially refracted. Now this one will be partially refracted and partially reflected, and this will be partially refracted and partially reflected. So this is what probably they are expecting. Apart from that, not only this one also is reflecting and refracting in the same direction. Now again this one is reflecting and refracting, reflecting, refracting. This is what they are expecting, but none of this is there. So I think both can be the answers because values were not given. Going to the next question. A light ray enters a spherical drop of water of refractive index mu as shown in the figure. Select the correct statement. Incident rays are partially reflected. See, there is refraction here. See, whenever there is refraction, there will be reflection also. Now here if it is total internal reflection, then we don't know, but they never mentioned anything, so there can be all the possibilities, right? Incident rays will be partially reflected. Incident rays are totally reflected, so we never know the information, but from the next questions you can understand there is a condition that needs to be satisfied for total internal reflection. So there will be partial reflection and partial refraction. Incident rays are totally transmitted through a point. Yes, total transmission will never happen, there will always be reflection. So option A we can go with, incident rays are partially reflected at point A. Now going to second option, second question. An expression of angle between incident ray and emergent ray. Okay, that's angle of deviation. They are asking what is the angle of deviation for the given figure. So basically this is the figure. This angle is phi. Now if it goes undeviated, it used to go like this, but now it is going like this. This angle is alpha. You can look into this triangle. This radius is r, this radius is r. So this angle is alpha, this will be alpha. This is phi, this is phi, this is alpha. So this will be phi minus alpha, which used to go like this. It bent like this by phi minus alpha. So deviation is phi minus alpha in clockwise for this refraction. Now there is reflection here. If there is reflection here, if this angle is alpha, this angle will be alpha. So this angle is going to be 180 minus 2 alpha. So it has rotated again clockwise by 180 minus 2 alpha. Again by symmetry I can show you that this angle is going to be phi minus alpha, phi minus alpha, phi minus alpha. So here it is phi minus alpha clockwise, pi minus 2 alpha clockwise, phi minus alpha clockwise. So summation of this is the deviation. This deviation plus this deviation plus this deviation will give you this much, which is option D for question number 6. The angle phi for which minimum deviation is produced will be given by. So deviation has to be minimum, that is first differentiation of it has to be 0. Now there are two variables, but we need to convert it into single variable. So the options were in terms of phi. So let me convert in terms of phi. So instead of alpha, let me put it as in the function of phi. So for that I will be using Snell's law. At this point 1 sin phi equals to mu sin alpha, 1 sin phi equals to mu sin alpha. So from here alpha is going to be sin phi by mu, sin inverse of sin phi by mu. Alpha is going to be sin inverse of sin phi by mu, right? So this is deviation. Now this is a function of phi. We need to see when it will become maximum. So first differentiation is going to be 0. This differentiation, it is constant. For this differentiation is going to be this thing. This differentiation is 2. When you manipulate it and when you solve it, you will end up getting option B, right? The next question goes like, figure A shows two thin lens L1 and L2 placed in contact with common optical axis. The lens, because of the nature is not specified, are shown as dotted lines. These lenses are made of same material. An object of size 2 cm is kept at a distance 16 cm from the combination. The image is obtained is erect and has a size 3 cm. Lens 2 is now removed. And screen is placed on the other side of L1 as shown in figure B, as shown in second figure. The object and screen are kept at fixed distance and lens is moved such that the position that sharp image is formed on the screen. Size of this image is 3 cm. Let the position of this lens be 1. The lens is now moved to another position. Sharp image is again obtained on the screen. The size of the image is 5 cm. Position 1 and 2 are 20 cm apart. So you need to find different things. So what I will be doing is, I will be going with the second situation. So that using the second situation is lens displacement method. I can use second situation to find focal length of the first lens. So I am going with the second situation. In the second situation, there is an object, there is a screen, and you will be moving the lens when you kept it somewhere. When you kept it somewhere, when the object length is 2 cm, image length is 3 cm, they said. Now, so basically you can see magnification is more. So lens displacement method V by U. So this distance has to be more than this distance. So that's how I have drawn the figure. Now when you keep moving it, when it comes to this situation, there will be again image, but magnification will be less. And yeah, you might have seen, like when I invert this figure, it is going to show this figure. So basically if this distance is x, then this distance will be x. We need to figure it out. I figured out and I wrote it as 40, so don't bother about that. And the distance between these two lenses is 20 given. So only this thing we know, and magnification we know. Magnification is 3 by 2. 3 by 2 is nothing but this distance by this distance. This is 20 plus x by x. So 3 by 2 is 20 plus x by x. From there I will be getting x is 40. I know this length. If I take this length as x, I know this length is going to be x. Right? Similar figure. If this is x, this will be x. Now magnification is 3 by 2, which can be given as v by u, 20 plus x by x. From there I will be getting x is 40. X is 40. Once I get x is 40, if this is 40, this will be 40, this is 20, totally it is 100. So 9th question, the distance between object and screen is 100 cm. Now once I know this, I know object length is 40, object distance is 40 and image distance is 60. I can use lens formula. 1 by v minus 1 by u equals to 1 by f, and I can get the focal length of the lens is 24, and it is plus 24, it is converging. So question number 10, okay, we can't do. So L1 we found, okay, this is f1, right, 60 and 40, yes, it is f1, it is not f2, it is f1. Okay, so f2, okay, then we need to see what is the combination, right? Okay, combination of the lens, I think that we can do much easily, right? So let us take the combination of the lens. So we have taken what's happening in lens displacement method, and we figured out the distance between the object and the screen is 100 cm, and the focal length of that particular lens is plus 24, which is converging lens, that is L1. Then they have given the combination. When there is a combination, they said object size is 2 cm and image is erect, they said erect, and it is magnified. So erect and magnified will happen for only convex lens as far as you have seen, right? So it will be on this side, convex lens. Erect can happen only when it is virtual for convex lens, right? And object distance is given as, okay, so basically this is given as 16. So by using similar triangles, or magnification is v by u, height of the image by height of the object equals to v by u, you can get this as 24 cm, or you can go with similar triangles, right? So you know object distance, you know image distance, you can use lens formula, and you can get the focal length as 48. So combination is going to act like a lens 48, and it is convex in nature, focal length is positive. So question number 8, it is going to act like a convergent lens of focal length 48. Now combination is going to act like this, and f1, that's not f2, that is f1, right? Okay, so combination 1 by f1 plus 1 by f2 equals to f. 1 by effective is 48, 1 by f1 is 24, f1 is 24. So from there you will be getting f2 is minus 48. The other way of saying it is negative focal length, it is concave in nature, and focal length is 48 cm. So question number 10, it is option C. Going to the next question. Consider Mercury rotating about vertical axis with a uniform angular velocity filled in cylindrical container. The liquid surface is curved. The figure shows cross-sectional view of curved surface. Ignore the surface tension and viscosity. Hints. Coordinates of focus of parabola x square equals to 4ay is given by 0, a. So basically that's a fluids question. So you are rotating, it is going to take a parabolic shape. So if I take this as origin, and this x coordinate is x and y coordinate is y, basically I am taking some imaginary cylindrical element of water here, and I will be writing the net force. When I go down, pressure will increase, so pressure here is going to become P0 plus rho gy, this height is y. So here the pressure is P0 plus rho gy, here the pressure is P0. Now the net force towards the center is P0 plus rho gy into a minus P0 into a, that equals to mass times of acceleration of center of mass. Mass is density into volume, this length is x, mass of the element into acceleration of center of mass. Center of mass will be here. It is performing circular motion of radius x by 2. So omega square x by 2. From there you will be getting y equals to omega square x square by 2g, which you might have seen in fluids. That's a parabola, and they are asking the slope. Anyway, in the figure they have given slope is tan theta. So dy by dx, when you do that, differentiation of this will give you this. So that is tan theta according to the figure given in the question. So tan inverse, this is tan theta. Tan theta is that thing. So you will be getting option A is correct, option B is wrong. Now they are asking what is the focal length. What you can do, you can compare this one. You can modify this equation like this, and they said this is like x square equals to 4ay. When it is of this form, A is going to be focus. And I have already made a video, I mean repeaters. If you are repeaters, you can see like I have already made a video for parabolic mirror. When you send rays parallelly, they will be meeting at one particular point which is called as focus, the same focus which you talk in math also, that is A comma, here it is 0 comma A, right? So I need to find, okay, so basically A is nothing but focal length. So in option C and D they are talking about focal length is 20. When will focal length will be 20? So if I substitute focal length is 20, omega will be 5. So basically it is going to behave like a mirror of focal length 20 when I rotate with angular velocity 5. Now, okay, this is the question I have done for repeaters in that doubt section thing. Right. Others can just pause and you can read by yourself, you will understand it. The solution was written in the next slide. Just math. This is from this triangle. Don't bother about that. That you can get it back quickly using Fermat's principle. So if they are meeting here, the time taken by all the things must be same. So it must be parabolic in nature, because the time taken for this guy from here to here is same as for this guy from here to here, here to here, here to here, here to here. Now this length is same as this length. This length is same as this plus this. This length is same as this plus this. So by Fermat's principle, if they are meeting, they must be traveling in same time. Quickest light will travel in the quickest path, right? So we can expect like that is parabola, because this distance is going to be this distance when it is a parabolic curve. The next question goes like, a small source of light is mounted inside a cylindrical container of height h. The bottom of the container is covered with mirror. Initially container is empty, then clear liquid with index of refraction n is slowly poured into the container. The level of the liquid h rises steadily, reaches the top of the container in time t. Let h1 be the distance of the source of the light from the bottom of the container. Consider paraxial approximation. So first case is when liquid is less than, liquid is below, liquid level filled is below the source. The second option is when the liquid level is above but not crossed the border. So basically this is the first situation when the liquid level is here, and they have given this total height is h, and this level is capital H, and source is at h1, and let me say I am observing from here, and distance from me to this surface is d. Now they have said it is constantly, it is steady rate, so dh by dt, this is increasing, right? This is increasing at a rate, and they said like it is going to fill a height h in time t, so const steady rate, so dh by dt is h by t. Now we need to see where the object is getting, where the image is getting formed. Now this is the object, rays will go, they will refract, so this distance is going to be h1 minus h. So this distance is h1 minus h. So after refraction we will be feeling like those rays are coming from here, whose distance is mu times of h1 minus h. So we will be feeling rays are, after refraction rays are coming from here, which is mu into h1 minus h. Now this will act as object for mirror. So what is the distance? Mu into h1 minus h plus h. So this will act as an object for the mirror. So image will be formed somewhere here, whose distance is mu into h1 minus h plus h. So image will be formed here at this much distance. So from the surface, so from the surface its distance is going to be that thing plus h. This distance due to reflection image is formed here, which is this much, this white color thing plus yellow color thing. Now those rays after reflecting, they will go back, they have to go undergo refraction. Now when they are undergoing refraction, that guy will be feeling those rays are coming from somewhere here, whose distance is h plus this thing, that thing is this, right? Now when this guy is feeling those rays are coming from here, after refraction the outside person is going to feel like those rays are coming from somewhere here which is less than the actual distance. So which is actual distance by mu. So the guy outside, he will be feeling the rays are coming from actual distance by mu. This is the actual distance by mu. So from the surface, that's the distance this guy will be feeling. But from himself, he will be feeling at a distance d plus that thing. Now this is the distance between observer and the image of the source, final image of the source. Now we need to see at what rate this is varying. So differentiation of this. So when I differentiate first term, I will be getting this thing, h and h, 2h. So when I differentiate this, I will be getting this thing, this thing. Now h1 dash is not varying, it is a fixed distance. So this differentiation is 0. H dash, this is increasing. So h dash is positive and it is going to be h by t. Anyway, let me keep it h dash. 2h dash by mu. And d dash. D is reducing. So d is reducing at the same rate as h is increasing. So d dash is minus h dash. So from here you will be getting this as the answer. No, anyway, we will be getting negative here. Obviously, see, they are talking about magnitude. We are going to get negative here. The meaning is it is going to decrease. So if option A is correct, then option C will be wrong. Now going to second case, again the same thing. Now there the rays will go directly, they will hit the mirror. So this object distance is h1, image will form at h1 and those rays will go through refraction. So this guy will be feeling those rays are coming from h1 plus h. So after refraction, the outside guy will be feeling those rays are coming from actual distance by mu, that is h1 plus h by mu. h1 plus h by mu. So this outside people will be feeling it is coming from a distance h1 plus h by mu, and from himself it is at a distance extra t. Right, now we need to see at what rate this is varying. This is a constant, so differentiation is 0. This thing is fine. D dash it is reducing at the same rate as h is increasing, so d dash is minus h dash. Again, that's also negative. They are giving only magnitude in the options, right? So option B will be correct, option D will be wrong. Okay, going to the next question. The refractive index of medium of certain region x greater than 0, y greater than 0 changes with y. A thin light ray traveling in x direction, a medium having refractive index mu naught equals to 1 strikes another medium of refractive index mu at right angles and move through the medium along the circular arc of radius r as shown in the figure. The material is with greatest known refractive index is diamond, but even the refractive index of the material does not reach the value mu max. It is the limit that sets the maximum angular size of the arc the light ray can cover. The angular size of the arc that is subtended. Angular size of the arc is the angle subtended by the arc at the center. Okay, they are giving the definition. They are asking how refractive index is varying as a function of y, and unit vector or the tangent, and what is the maximum angular size of the arc. So basically this kind of question is there in your package, you might have already seen. Because of the variation in the refractive index, the wavefront, if you talk about the wavefront, some things will be having less speed, some things will be having more speed. So in the next moment, wavefront is going to look like this, curved. So the ray is going to be curving, and we can explain wave nature using only wavefront probably. So anyway, that's curving. And they said it is going, now let me say this is the slab given in the question, and they said it is going to perform a circle. It's not a full circle, they said it is an arc, but I have drawn full circle for my reference. And they have taken this as origin, so equation of this circle is x minus r whole square plus y square equals to r square. So I don't know why I differentiated it, probably like we'll see later. So now I have taken the ray is going like this. So here I have drawn the normal, I have taken this angle as theta so that I can apply Snell's law. If this is theta, this will be 90 minus theta, this will be theta, this will be 90 minus theta, this will be 90 minus theta. When I drawn the tangent here, that is 90 minus theta, so this is also 90 minus theta. And if this coordinate is x comma y, then this length is y, then this length is going to be r minus y, because this total length is r, right? So this is r. So that everything you can manage. Now you can apply Snell's law. Now they are like different slabs, so you can apply Snell's law and you can say mu sin theta at any point equals to mu sin theta at any point. So mu sin theta at initial point equals to mu sin theta here. So 1 sin 90 initially the ray is coming like this is the normal, right? 1 sin 90 equals to mu sin theta here. So from there you will be drawing the triangle, because you know in all these kind of questions the two things what we will be doing is, one is Snell's law, one is slope of the tangent. Now what is the slope of the tangent? Tan of 90 minus theta, which is cot theta. So dy by dx equals to cot theta. So probably for this reason I might have differentiated it. Anyway, yeah. So from here you will be getting sin theta, from here you can get the cot theta also. Sin theta is 1 by mu, so from the triangle you will be getting cot theta. From the triangle cot theta is root of mu square minus 1. So dy by dx from here, no, okay, I don't think I have used it. It's not, I didn't use that. I used cot theta from this triangle. From this triangle, cot theta is this length by this length. This length is root of r square minus r minus y whole square. Yeah, so I didn't use this. I have used the triangle. I have used Snell's law and I found what is cot theta. At the same time, I have found cot theta using this triangle. And yeah, so, and I can see like, yeah, I modified the equation and you can see like mu is equals to r by r minus y. That is option A is correct. Now, once you know option A is correct, you can do many other things. You can see option B. So when y is r by 2, I can apply Snell's law from first point at any point, right? So at the first point 1 sin 90 at r by 2, it's going to be mu at r by 2 into sin theta. So that theta is going to be half. So sin theta is going to be half. That is theta is 30. This theta is 30. So this is 60. So refracted ray is going this way. So what are its components? 60, 1 cos 60, 1 sin 60. 1 cos 60 is 1 by 2 along x axis, minus root 3 by 2 along y axis, right? So option B is correct. Then the maximum angular size, that is 90 minus theta. This is this maximum value, this value they are asking, right? Now there is a limit for this value, we understood. Mu value is going to become maximum of 2.5. So let us find what is this maximum value. Let me call it as beta. So what is that? That is going to be sin inverse 2 by 5 when you apply Snell's law. 1 sin 90 equals to mu sin theta, mu max, so beta value. So once you know beta, but what we need 90 minus beta. We need 90 minus beta. So answer we need is 90 minus beta. So cos of whatever answer we need is cos of 90 minus beta, which is sin beta. But what is sin beta? Sin beta is 2 by 5. So cos of our required answer, that is angular size of the arc. See, we have taken theta as some other thing. They are saying theta is angular size of the arc. So I didn't mention about that. So you don't read it as theta in the options. You read it as angular size of the arc. That is beta for, answer for us. That is 90 minus beta, right, which will turn out to be 2 by 5. So basically, we need to find what is this angle. That angle will turn out to be cos inverse 2 by 5, right? Going to the next question, the figure shows an incident ray at an angle 60 degrees. If the plot shown the variation of r minus y versus k, where k is mu 1 by mu 2. Okay, so yeah, let me show you the figure. So that's the figure. This angle is given as 60 degrees, and where r is the angle of refraction. Okay, so from here to here, k value, when k value is increasing, mu 1, okay, let me say mu 2 is fixed. So if k value is increasing, the meaning is mu 1 is increasing. When k value was 0, then mu 1 value was, like when k value is just greater than 0, this is just greater than 0. The meaning is this angle is going to be more than critical angle. This angle, when this refractive index is very small, then the critical angle is going to be very small. So 60 degrees will be more than critical angle, there won't be any refracted ray. So till some particular value of k, there is no refracted ray. The meaning is for all those conditions, 60 degrees is more than critical angle. Now when it starts refracting, then this 60 degrees is going to be slightly less than critical angle. So we will talk about like that changeover case, that critical case. So when will this be critical angle? For what value of mu 1 by mu 1 and mu 2, that will be critical angle. I can apply Snell's law. Mu 2 sin 60 equals to mu 1 sin 90. Mu 2 sin 60 equals to mu 1 sin, okay, I didn't use that, I just used r, but I can use 90 in order to get k1. Anyway, we will see that. So from here sin r will be this thing. Now we want to see this point where refraction will start coming into picture. So when it will start coming into picture, when this is going to be just less than critical angle, right? So when this is going to be 90 degrees, so k1 value is root 3 by 2. So when k1 value is root 3 by 2, what will happen? This ray will be just grazing the surface. Till then, no refracted ray will be there. Now after that there is a minimum here, we will see why there is a minimum there. Deviation, in fact, that is 0, that is 0. When will it be 0? The meaning is angle of refraction and angle of incidence is same. When will that happen? When both mu's will be same. So that is k2 equals to 1, right? Okay, anyway, once you get k1, you can get theta 1 also. Once you get k1, so once you get k1, what is happening? We said that 60 degrees thing is grazing the surface, right? So 91, one is 90 degrees, one is 60 degrees, so deviation is going to be 30 degrees. Deviation is going to be 30 degrees, right? Now what about theta 2? What is theta 2 case? K is further increased. When K is further increased, what will happen? This one will further increase, further increase, further increase. After that, you can see the deviation is going to be the same value. So the other way of saying it is, yeah, so when this value will be keeping on increasing, then this will be bending towards the normal. When it is bending towards the normal, like eventually it will be bending towards 90 degrees, right? So it used to go like this. This angle is 60. This angle used to be 60. It has bent by 60 degrees. So theta 2 is going to become 60 degrees. When this becomes very large, this ray is going to be almost towards the normal, which has bent by angle 60 degrees, right? So it's not reflection. Next question goes like, a plane mirror M is arranged parallel to the wall at a distance. Okay, I'll read the question by putting the. A plane mirror M is arranged parallel to the wall. This is the wall. It is arranged parallel to the wall at a distance L from it. The light produced by a point source is kept on the wall, is reflected by the mirror and produces a patch of light on the wall. So there is this thing. I have taken symmetrical, you can take unsymmetrical also, that's up to you. Okay, so and this is moving towards the wall, then what will happen to the image? This is the question. So basically the rays, anyway, I have taken only 2 rays. So this ray which is going like this, it will be reflected like this. This ray which is going like this, it will be reflected like this. All the rays in between, they will be reflected and they will be making a patch. So for this thing, you will be getting a patch of image. Now instead of looking at this wall, it's always better to draw the figure here. So you just extend the rays, right? I mean, obviously, like if this is the object, image is going to be this one, right? So you just extend these rays. I mean, this one is not needed, these rays are not needed. And so these are not rays, this is for my reference to say like this image will, this length will be same as this length, right? So these are the incident rays and these are the reflected rays. I just extended them. So this basically image, this length is going to be, patch length is going to be this length. Now why I have drawn it is to show you like if this length is L, this length is going to be L. Now you can see a similar triangle here. I mean one triangle here and one big triangle here. Those triangles are similar to each other and this length is L and that bigger triangle length is 2L. So if this length is M, this length is going to be 2M. If this length is 2M, this length is going to be 2M. It has nothing much to do with L. So if you reduce this, this one also will reduce, but those similar triangles will always be in the ratio of 1:2. So the patch of light will move with the speed V on the wall. No, its size will always be same. Option A is wrong. Patch of light will not move on the wall. Obviously it won't move. As the mirror comes closer, the patch of the light will become larger. No, it's of the same size. The size of the patch will remain same. Yes, option B and option D are correct. Going to the next question. In the shown arrangement, a point source is placed at 60 centimeter. This is 30, this is 40, this is 20. Yeah, you can find where is the image formed because of this lens. You can use lens formula. 1 by B minus 1 by U equals to 1 by F. U is minus 60, F is 30. When you substitute, you will be getting V is plus 60. The other way of saying it is, when the mirror is not there, they would have converged at 60. But they have placed it in such a position that this is 40 and this is 20. So you can see center is at 60. So these rays, they are supposed to meet here, but you are placing the mirror, but you are placing in that particular manner that they are supposed to meet at the center. The other way of saying it is, they are going to hit the mirror perpendicularly. Then they are going to retrace the path. So image will be formed here. Final image will be formed here. They said this is the origin, so this x coordinate is minus 60. See, they said object is somewhere, but they are talking about only x coordinate. So I just put the object here, right? That doesn't make much difference. So answer is going to be minus 60. That is 10k is minus 60. Fine. The next question goes like, a man of height 2 meters stands on the straight road on a hot day. The vertical temperature of air results in a variation of refractive index the actual length of the road. See, this question is similar to your package question. It's the same thing. Whatever you have done here, you have to do the same thing there. This is the answer for the package question. What we have done, we have used Snell's law and we have drawn tangent and slope of the tangent. I have just borrowed those results. I have applied Snell's law at the initial point to the any point, and I have used slope of the tangent. From here I can get sine theta, and I can make a triangle, and I can get cot theta from here, and I can substitute it back here. Mu value is given, I can substitute it. Then I will be ending up with this one, and I will be integrating when x is 0, y is 0, when x is x, some y. So basically you will be getting the equation of the curve. So in your package question, this is the equation of the curve. Now also it's like the same. So in your package question, this length is given as 2 meters. Now instead of slab, they are saying man is there and his length is 2 meters. So basically you need to find what is the x coordinate, what is this length, that much only he can see, right? So you need to find x coordinate, that's the question, where y coordinate is 2. Where y coordinate is 2, you should find what is the x coordinate, that is 2 kilometer, right? The next question, a ray of light from liquid root 3 is incident on the system of two right angle prisms of refractive index root 3 and root 2. The ray suffers 0 deviation when emerges into air from CD. The angle of incidence I is. So basically this medium is root 3 and this medium is root 3. So this ray will go undeviated. If this is I, this will be I, this will be 90 minus I. If this is 90 minus I, this is 90, so this will be I. If this is I, this will be 90 minus I, if this is the normal. Now there will be a refraction here, and this is less, so it will be bending away from the normal. Anyway, after that it will be hitting here, and this is the normal. I am calling this as R so that I can make it 90 minus an easy thing. So if this is R, this is going to be 90 minus R, and this is 90, so this will be R. If this is R, this will be 90 minus R. So this is I, this is 90 minus I, this is R, this is 90 minus R. Okay, this angle I am calling it as some capital I. Now I am going to show you this capital I is nothing but same as this small I, because they said angle of deviation is 0, right? Now here what is the deviation? This is the bigger angle, so we choose it to go like this, but it bent like this. So 90 minus R minus 90 minus I. 90 will get cancelled, you will be getting I minus R. Deviation here is I minus R. So deviation here it is clockwise, here it is anti-clockwise. Here the deviation is I minus R, capital I minus small r. Here it is small I minus small r, here it is capital I minus small r, but we know the total deviation must be 0. So this thing must be same as this thing. So that is small I minus small r must be same as capital I minus capital R. So basically capital I is nothing but small I, that's the thing. After that you can use Snell's law here, you can use Snell's law here. When you use Snell's law here, you will be getting root 3 sine 90 minus I, that is root 3 cos I equals to root 2 sine 90 minus r, that is root 2 cos r. Thereafter you can apply Snell's law here and you will be getting this equation. You need I, so you need to eliminate r. So find cos r from here, find sin r from here. Cos square plus sin square equals to 1. Just substitute it back and you will get the answer as cos I is 1 by root 2, I is 45 degrees, that is pi by 4 radians, right? So the next question goes like, a parallel beam of light is incident on a transparent medium enclosed by surface AOB. They didn't say what kind of surface it is. Convert just to a point F such that OF equals to F. If the maximum radius measured from O, so the maximum radius of the beam that can be focused. So basically beam is like this, and that radius is R. So this is R, this is R. So beam is going in this much. Diameter is 2R, right? Can be all, this entire beam can be focused at the some point. So that maximum radius is, if it is R, then F by R is root 2 given in the question. Then find the refractive index of the medium. So again we will be going with the Snell's law. So if the rays are meeting at a particular point, then all they are going to take same time. So from here to here all are going to take same time, but here speed is going to change. Now instead of calculating what is the time separately, I am going to change every length into optical length, because optical length is nothing but the time whatever time taken to travel this much length in this medium is same as whatever time taken to travel optical length in vacuum, right? So I will be converting everything into optical length. I am going to take this as x. If this is x, this will be x, and this length is f given, so this is f minus x. this is r, so this is r, this is f minus x, so this is going to be hypotenuse, that is root of r square plus f minus x whole square. So now this length, if I want to convert it into optical length, it is going to become mu into x. Yeah, so anyway, this total length is f, right? See, the time taken from here to here is same for all, because you can see that you can draw the wavefront and you can see like the time taken must be same. Now from here, different people are following different paths, so I am taking the time taken by this guy must be same as the time taken by this guy. Now this length I am going to convert it into optical path length. This length is f, so optical path length is going to be mu into f. This length is in vacuum, so its optical path length is also x only. This length I am going to convert it to optical path length, which is going to be this thing, mu into length, right? So if this guy has to cover this much distance in this much medium, so the time taken will be same as some other guy to cover this much distance in vacuum. That's the meaning of optical path. The time taken by this guy to travel this much distance in this much medium, is equals to the time taken by some other guy to travel this much distance in vacuum, right? So this optical path length must be same as this optical path length, so that's the only thing. Thereafter you square it, modify it, you will be getting a quadratic in x, and you know x has to be real value, so discriminant has to be greater than or equals to 0. From there you will be getting r minimum value. Anyway, they are asking r maximum value, r has to be less than or equals to, right? So maximum value you can find. So instead of that inequality thing, I am just equating it, because that's how generally we will be solving. Thereafter it's only manipulation, we will be getting mu equals to 3, right? Going to the next question, a plane mirror is placed with its plane at an angle 30 degrees with y-axis. Plane of the mirror is perpendicular to xy plane, and the length of the mirror is 3 meters. An insect moves along the x-axis starting from a distant point with speed 2, the duration of time for which the insect can see its own image. So basically, when the insect is along this perpendicular to this end, like only in this region it can see its image, because this ray it can see back. But if the insect is here, whatever ray is hitting here, it will go like this, whatever ray is hitting here, it will go like this, so it can't see. So once it enters this region, it can see. Once it enters this region, the ray which goes like this, it will be reflected back, right? Similarly, you can see one more ray also. So basically, once he crosses this region, he can see the image. That's the idea. So from here to here, he can see the image. This length is 3, this angle is 60, so this length is going to be 6 meters, and he is moving 2 centimeters per second. So the time of journey from here to here is 6 meters by 2 centimeters per second, which is 300 seconds, right? Thank you.